Now start.
Good morning everybody. So today we are going to start light, reflection and refraction. So first of all, what is light? You may observe that in a dark room we cannot see anything. Nothing is visible to us. If in a dark room the chair, tables, anything is kept, we cannot see anything. But as soon as we turn on the lights, that visibility comes to us back. We can see everything. So what makes this visibility come from after the light is turned on? Actually what happens, if any object is there and here is the source of light and here is an standing here, and if a person is standing, so when the ray of light comes from the source and gets reflected from the object, it gets back to the mirror. 1 minute. It gets back to the person and is perceived by the eyes of that person, and hence that person is able to see that object. This way we are able to see objects everywhere around us. If in a room, if light is turned on, through this process we are able to see objects. And this is the phenomenon of many common wonderful things around us. For example, the rainbow, the wonderful colors of a rainbow, the image formation by mirrors, everything. Using this phenomena, we can see those wonderful things. So, we can also point out the properties of light by such phenomena. From this, you may understand that light travels in straight lines. You saw that from source to object, light travels in a straight line, and from source to that person, light also travels in a straight line. It's reflected in a straight line. So, for example, like if an opaque object is kept in path of a light and that object is very small, so light has a tendency to bend around it. You try one activity. You take one thread. Take one thread. Here is a wall. And here is the source of light. We know that thread is very thin, very thin. A thread is very thin. If we pass a ray of light here, light has a tendency to bend around it and go to the wall. A phenomenon called diffraction of light. This phenomena is called diffraction of light. Why? Because light is thought of a source of energy which is consists of small particles called photons. Light is thought of a source of energy which consists of small particles called photons, and since we know that a thread is very thin, these photons just bend around it and then fall on the wall. So this contradicts the fact that light travels in straight lines. This fact that light travels in straight lines was applicable until only 20th century and was given by Isaac Newton. This theory of straight line was given by Isaac Newton until the 20th century. Until the 20th century, this photon theory was given by Isaac Newton. But after 20th century, Huygens, a scientist named Huygens, after doing this experiment, told that light is a form of wave. Light travels in a form of wave was told by Huygens after doing this experiment. So we got two theories. Light travels in straight lines was a theory given by Isaac Newton. He told that this source of energy consists of particles called photons, and thus this visibility of object on the wall, the shadow formed on the wall of this, is dependent on the intensity of the photons that falls on the surface. Like how much photon will fall on this wall that much darker shadow we will be able to see. Since this piece of thread is very thin and that light bends around it with the process of diffraction, very less amount of photons are able to concentrate on it and fall on the wall. That's why we see a very light shadow of the thread here on the wall. So this contradicts the fact that light travels in straight lines, and Huygens told that light travels in the form of a wave. We have studied in class 9 that wave travels with the help of vibration of particles from one area to another area. Like if there is a particle here, then it will not move anywhere. It will vibrate about its mean position, either left or right, or either up or down, either this type or either this type. It will vibrate about its mean position and transfer its energy to the corresponding particle, and this will be carried on until it reaches its destination. This way a wave travels, we have studied in class 9, and this type of theory was given by Huygens after the 20th century. But later on, many told that light is neither a wave nor a particle. So, but still this is considered. Still it is considered that some say that light travels in waves, some say that light travels in straight lines. So in this chapter we are going to study the particle nature of light. That is, light is travels in straight lines, and we will study reflection, diffraction, that are also examples of particle nature of light. So let's start. So we will study now reflection. What is reflection? I drew a diagram and told you that how the ray of light reaches to a person. For example, suppose this is the reflecting surface. For example, wall. This is a plane. So if here is a source of light, sorry, not here, it will be here. Light ray will come here. This way it will come. This is called incident ray. It will then bounce back off the surface like this. This is called reflected ray. So you see that the bouncing back of light after touching a surface, reflecting surface, and coming back towards another direction is called reflection. This process is called reflection, or this phenomena is called reflection. What if we draw an imaginary line from here? We name it N. We draw perpendicular to the surface from here. This is called the normal. It is an perpendicular imaginary line drawn from the intersection of the two rays to the surface. This is called the normal. This angle formed between the incident ray and the normal, formed between the incident ray and this normal, is called, represented by I, and is called the angle of incidence. And this angle is represented by R and is called angle of reflection. So these are the concepts in reflection. The ray of light coming from the source which touches the surface is called incident ray. The ray which reflects back is called reflected ray. The angle formed between the normal and the incident ray is called angle of incidence. The angle formed between the normal and the reflected ray is called angle of reflection. and this is the reflecting surface. We can take wall light, anything. So this is the concept of reflection. Now reflection has two laws we studied earlier, that reflection has two laws. First is that angle of incidence will be equal to the angle of reflection. This is the first law, which means this angle of incidence will be equal to the angle of reflection. Second law, you can see here that the incident ray, reflected ray and the normal all are in the same plane. So our second law comes that the incident ray the reflected ray and the normal all lie in the same plane. So these are the two laws of reflection.